Okay, so I have a question from Kinetics for you. Let me read this question out quickly. The following mechanism has been proposed for the reaction of NO with Br2 to form NOBr. And here are the reactions. All right, you have NO and Br2, and they give you NOBr2, not NOBr. There's a double-headed arrow here, which means that there's an equilibrium that we are talking about. So let me just quickly write capital K over here for this equilibrium. And then that NOBr2 reacts with NO and gives you NOBr, which is the final product. And here, this is a single-headed arrow. So I'm just going to place a small k here to show that this is a rate constant. Okay, so this is equilibrium and this is rate constant. All right. Now, the next line reads that if the second step is the rate determinant step, or the RDS, the order of the reaction with respect to NO is what? This is an interesting question. Why is this interesting? We're talking about time, right? If this is a rate determining step, you right away know that this is the slow step, the second one, and this is the fast one. So here we talk about time. And right here, we also talk about energy. If you talk about equilibrium, yeah, this is an energy idea. Now, any reaction or process has these two ideas attached to it, the idea of energy, idea of time. Energy is what drives a process or a reaction, and time is what makes it practical. Yeah? Even if something may be energetically favorable, it may or may not happen depending on how much time it takes. All right, so this is why I find this question to be very interesting. On to this, the method of solving this. If the second step is rate determinant step, the order of the reaction with respect to NO is what? It looks like it should just be, the rate could simply be written as the rate constant K times NOBr2 times NO, which means that the order would probably be 1. This is not the correct answer because this is not the overall order. NO is also reacting with Br2 to give you NOBr2 in the first place. So if you jump the gun here, you could get this incorrect very quickly. But hey, if we do it slow and steady, there's no way to get this question wrong. All right, which is what we're going to do. First, we've got to get rid of this NOBr2 and get NO back in the picture. We'll do that by using the energetics idea from chemical equilibrium. And that's about it. It's a very straightforward question if you catch that one simple idea. And also you could, well, mess it up if you just do it quickly. So let's go ahead and solve this question. We have, I'm just written down the equations once again, yeah? The first and the second equation. Order can be figured out from the from the second reaction, which is a slow step, the rate determining step. I've written small k here, and then we have it in terms of NOBr2 and NO. And then NOBr2 is in equilibrium, so there's a capital K over here to represent that. A simple idea, yeah, you have products by reactants and stoichiometric coefficients, multiply them, all of that, the usual stuff. And then we get NOBr2 in terms of, well, the other reactants, the original reactants, right? These are the original reactants right here. Once we do that, we got to just substitute this back into this, and we can get the order of NO. That's about it. So we do that here, and the rate now is equal to just multiplying both of these, yeah, small k and capital K. Remember, for kinetics, we use small k, which is the rate constant, and capital K talks about equilibrium. Okay, this is a convention, and usually the equilibrium constant is equal to small kf by small kp. A bit of theory, if that it's good to keep this in mind while you're solving questions. You don't need that specifically, especially this part here, but it's good to always remember this theory and also do this. Anyway, so the rate here would be, this should also be a small k. Yeah, I was just telling you that how important it is. Anyway, so yeah, you get this, and I put another k dash over here, and that's NO and NO whole square into Br2, which means that the reaction is in second order with respect to NO and not 1, as I told you was the incorrect answer. So the answer here is, well, this one right here. Quick recap. There are kinetics and energetics ideas being used in this question. We first use the kinetics idea to form the equation of rate constant, which was this way, and then we get rid of NOBr2 by using this equilibrium idea, which is a fast step. That's it.